In this video, I'll show you how to formulate the correct distance the car should drive with relation to the wheels rotating. But first we need to get the circumference of this wheel to plug it into a formula. I've used the line tool under Scene, Create Geometry Line, and I've created a couple lines on either side of my tire. So I'll isolate these parts. And then I can use a measuring tool under Interaction Measurement to measure the distance between those. So I'll create a line to object measurement, shift-click on the first and second curve, and that gives me a distance of 681, which is also the diameter. So to calculate the circumference, I just need to multiply that number, 681, times pi, which is 3.14. So my circumference is 2138. I need another bit of information, so I will look in here at one of my tires, and I see that the last key is set to a value of negative 1080. I'm just going to delete that measurement. And I can see from the shadow baked on it that it rotates a few times. I'm not sure exactly how many, but I can just calculate that by dividing the number 1080 divided by 360. So that gives me 3 revolutions. So now that I have these 2 bits of information, I just need to take the circumference, which was 2138, and multiply that by the number of times the wheel spins around, which is 3. So I get 6414. So this should be the distance that my Genesis drives forward. So looking at my last keyframe, I did preset it to the correct distance. And to check it, we can go back and try it 1 revolution at a time. So if I just take the first part of that formula, which was the circumference 2138, and I multiply it by 1, then the distance should be 2138. If I multiply it by 2, then 2 revolutions should be at 4276, which they are. And if you need a number, we'll just go to some random frame. Instead of doing the math, you can always set your post-infinity mode to linear and then just key that channel. And you can see that it did continue in the same trajectory and figured out the exact distance that the car should be driven, assuming the vehicle continues at the same rate of speed. If instead of being provided the distance the vehicle travels, you have instead how many times the wheels spin around, you can use a similar formula. I would just take that distance driven, which is 9139, and I would divide that by the circumference, which is still 2138. So this is telling me that the wheels should rotate about 4 1/4 times by the time it gets to this frame. So if I open my calculator and I say 360, which is 1 revolution, times 4 point, what was it? I don't remember, around that. So we should get to somewhere close to 1530. Let's see if it does when I set an infinite key on 513, my last frame. I'll just key that, and yes, it's very close. So a lot of this is being a perfectionist. Of course, by eye, no one's going to be able to tell unless it's way off. So this is just some helpful tips to help you get closer to making sure that when your car drives, that the wheels are correctly rotating.